The primary aim is to try to get people who are learning programming, people learning about systems, people are learning about human factors and those things, to just have enough knowledge of security that they don't look stupid when they go out to industry. So that's the primary aim of it. What's the problem solving? Well, these kind of things are pretty well established by industry folk if you talk to them, which is that when our graduates, and even your graduates, go into industry, we find that they don't know enough about security to actually do the job that we think we've trained them for. Now, this isn't student motivation. We run a Capture the Flag weekend at York, and we get about 120 students every year, and they're excited by it. They're interested in the problems that security arises. But we haven't managed, in the first and second years yet, to properly embed it in all of our teaching. And so, government has got to be in its point about this. And you know what happens when governments have bees in their pockets? Which is they use all the levers they've got available. And this is one of the levers they've got. Funding is another lever. Regulation is another lever. And we're seeing all of these things gradually pressurize us on undergraduate courses to do something sensible about security. So this isn't a problem that's going to go away. What we're trying to do is to work out how to help engage students in cybersecurity. And students of computer science, we're not concerned here with students who are specifically undertaking security courses. And particularly this one, we've got an awful lot of lecturers who are simply brilliant at what they do. We've got network people, we've got database people, we've got programming people, all of those subjects we teach in computer science. All we're trying to do is to give them a little extra to include into their courses so that they can do security at the same time. This project is limited to doing something quite simple, which is develop some small practical exercises which subject matter experts can use within their modules, embedded in order to inject some security ideas and teaching and thought into the whole process that we use to educate computer science students. So why is it difficult? It's difficult because of the difficulty of getting the right expertise in the right place, because people who are experts at programming often aren't experts in security. They may not be current in what compilers do, for example, to protect against security, or they may be expert in other respects. Similarly, database people, networks, all those things. So it's difficult because of the expertise, and it's expensive because developing good practicals is expensive, despite the fact it's one of the important things that we do in education. So supplementing material, we're not in the business of writing whole modules. We're not in the business of trying to write courses for people. We're just in the business of trying to provide some practicals that help. So we're trying to allow people to maintain their own distinctive courses, teaching the way you teach it in the modules that you teach, but add some distinctive security in the same course. And in the process, embed it. One of the things that we're not covering here are security subjects which are really best entirely separate security subjects and treated left separate alone. So you might run a complete module, for example, in security management and risk. It doesn't kind of fit into an ordinary programming module or those kind of things. So it is not part of this agenda, although it's important. And as I said, we're aiming at years 1 and 2. So we're aiming at the compulsory courses at the bottom end of the computer science world. It's funded by the Higher Education Academy. You will find, if you look on that website, there are a range of projects. And all of those projects are intended to be for the whole community. You'll find that quite a lot of them are aimed at higher levels and at masters. But those of you who are looking for security input into courses, which is being developed with the intention of being used by the community, you'll find a lot more projects there as well. This is one of the few ones that's aimed just at the undergraduate level. So have a look there. There's some interesting stuff going on. And there's some stuff going on that people can use. So, what have we done so far? Mostly planning. We've taken a lot of input from students, academics at York, and partners being industry people. And we've had a lot of really quite interesting ideas. One idea, for example, was to do everything in hardware. You know, we should simply do all of our examples using Raspberry Pis or whatever the current equivalent is. And actually, we did a couple of weeks' work on that and discovered that it works brilliantly, except for the fact that you need some rather expensive hardware in order to take measurements of such things. They're so fast these days, you need exotic data capture equipment to be able to do some of the experiments with them. So we've gone back to virtual machines, rather simple time machines. You can package up something and give to somebody and anybody can run. And that's essentially how we'll be delivering these things. And with our own courses, documentation would include student workshops and student answer sheets, so that students can actually take the stuff away and work in their own time as well with it. So fairly standard kind of experiments. The experiments that you could expect to do perhaps in an hour, we're not looking at whole days or whole half days, we're looking at bite-sized things that you can therefore fit into courses rather easily. And what you'll find on our website, which I'll give you later, is a batch of these. A generic module title, which is the kind of module into which these things might fit. And we haven't gone specifically for your modules, we've gone for quite generic computer science type topics, which we hope you can kind of make sense to. Some people will actually take some of these experiments and fit them in a different cross project, but we're just trying to give some clustering. Some of the issues we're trying to address, which, if you're smart, you might turn into learning outcomes, but they're probably at a little low level for that at this stage. And then the kind of experiments we might actually mount, 2 or 3 experiments for each. And that results in a lot of experiments. We're talking about 1, 2, 3, 4, 5, 6, 8, 7, 8 or so main topic areas, 3 or 4 experiments for each. We're talking about a lot of small experiments rather than a large number of big ones. And it's interesting. It'll be interesting to speculate at the end of the year how much of this we actually managed, because this is only a 1-year project. But this is the way the drivers that have been advising us and criticising what we've been talking about have taken us. And that's so far planned. The first couple of months we've spent some time talking to people, doing some experiments with delivery mechanisms, trying to get an agenda together. We've got a website there with a whole list of those things on, which I'll show you in a minute, and I'll give you the web to in a minute. And we're still open to ideas. I can't obviously build you a specialised left-handed compiler that only runs on 4th, or whatever your current, fun is. But please, this stuff's got to be useful to everybody. And so whether the kind of things we're talking about are generic and useful is important feedback. And whether you're interested in becoming involved in it, whether in whatever ways it's interesting and important. Just a quick proof, 2 slides, that this isn't just completely slideware. So an experiment, briefly. I type in a search query into Google, and we know what happens next. It goes out encrypted, using decent encryption. If we capture the packets, because we've got query help turned on, it sends each character as we type it. So we can record the time between the packets which carry the characters, which are pretty easy to identify. What happens next? Well, the answer is that if we've got a typing sample of the user, we can start to do some statistics on this. We can have great fun. We can actually we can work out the most likely characters in each position. In the good old days of cryptography, people used to have to read sentences out of this stuff. But these days we can get kind of probably better scoring rates. You could read the original word if you tried quite hard, but of course we can do better than that because we can use dictionaries. So we can also score against dictionaries and get the word out that the person typed with a reasonable degree of security in the first few. So good encryption and rubbish protocol. Use of security is quite important, how you use these things. And so we're not focusing here on breaking complicated encryption algorithms. We're focusing on good workmanship in computer science. This is particularly bad workmanship in computer science, by any definition. And it's quite easy for students to sort of play with these things. And of course, there are some quite useful lessons here in straightforward computer science, which is, this is information theory. We can actually work out how much information is in this system. We can work out how much information is given by the typing speeds versus the actual character frequencies. And we can look at the whole issue of side channels in cryptos and why small leaks matter. Small leaks matter if it's your key or if it's your password or if it's something like that. Guessing words can be quite helpful. So with quite simple experiments, we can actually do some stuff that's quite interesting. And that's about all I was going to say, which is to try to give you some idea of the small scale, large number of experiments incorporating existing courses. and attempt to provide a platform for people to use for themselves.